Yesterday we talked about Alexander Hamilton's method, and today we are going to talk about Jefferson, Adams, and Webster. So, Thomas Jefferson, you may have heard of him. He's on the nickel. He came up with a method that works a little bit differently, and his method was used for pretty much the first apportionment of our House of Representatives until 1840. It's also still used today in a lot of countries. He had an idea of, let's take our standard divisor and tweak it so that when every state's quota is rounded down, you don't have any surplus seats. Remember, traditional rounding doesn't work. So we start off with our divisor, and we're going to modify it. Now, how do you decide what to do? Well, it's mostly a little guess and check, but you find the standard divisor. You use the standard divisor to find everyone's standard quotas. And if you take those standard quotas and round them all down, so you give everybody their lower quota, obviously that's going to be too few seats, which is what we discovered with Hamilton. Hamilton then would say, okay, what you're going to do is give away the extra seats. Jefferson said, no, don't give away the extra seats. Instead, change your divisor. Okay, if you take your divisor and make it a little bit smaller, then when you divide everybody's population by that standard, by that modified divisor, it's going to make not a standard quota, but a modified quota. And if you do this in such a way that you can round all of those numbers down, you may get the right number of seats. Okay, now you come up with this number, again, using a little bit of guess and check. All right, so in practicality, here's what it looks like. So here's our Parador's Congress. Okay, we've talked about this a couple of times now. We have our populations. Here's our standard divisor, which we discovered was 50,000. We found everybody's standard quota. Remember, your standard quota is your exact fair share. If you take everyone and you round them down, obviously that's going to be too few seats. And again, this is where Hamilton would pick up and say, okay, now give away the extra seats. Okay. Jefferson says, no, don't give away the extra seats. Instead, change your divisor. Instead of giving away one seat for every 50,000 people, what if we gave away one seat for every 49,500 people? Now, he came up with this number through a little guess and check. So this number has already been through that process so that we know that it works. So you take your population, and instead of dividing by your standard divisor, instead you're going to divide by 49,500. So this 1,646,000 number, if we divide that, we end up with 33.25. And if we round down, we get 33. And if I take the 6,936,000 and divide by 49,500, it comes up to 140.12. And that rounds to 140, or rounds down to 140. If I take 154,000 divided by the 49,500, I end up with 3.11. If I round down, I get 3. And so on, taking each of these numbers and dividing by the 49,500, I end up with 42.24. Rounded down gives me 42. 685, I divide that by my modified divisor, I get 13.83, which rounds down to 13. And this one here at the end gives me 19.95, rounded down gives me 19. And this was constructed in such a way that by using this smaller divisor, when I take 33 plus 140 plus 3 plus 42 plus 13 plus 19, I end up with the right number of seats. And you would start off saying, well, it's very fair. It's fair because everybody gets treated exactly the same. Everybody receives one seat for every 49,500 people in their population. There's no giving away of extra seats. Everyone is rounded down. Everyone receives their lower quota. And it always gives you the exact right number of seats. So it's not like traditional rounding where sometimes it's good and sometimes it's not. Okay? It seems really great. And it was so great that they used it for years and years and years and years until somebody noticed this one time. If you look at State B here, State B's standard quota is 138.72, which means they deserve exactly 138.72 seats. That makes their lower quota 138 and their upper quota 139. So the quota rule would say, State B, because they deserve exactly, standard quota is your exact fair share, 138.72, they should either receive their lower quota or their upper quota. What they got was 140. That's higher than their upper quota. In other words, Jefferson's method has this tendency, since you make your divisor smaller, it divides in more often. It gives you away more seats. Sometimes it gives away way too many seats. And it causes upper quota violations. Okay, so by changing your divisor in such a way that you round everybody down and round everybody down to give you the right number of seats, it seems great, but it causes the upper quota violations. So Jefferson's method, again, was used for a very long time. People didn't recognize this was an issue. Same method, really. John Quincy Adams came up with a method as well. His says, let's find a suitable divisor. In other words, let's take our standard divisor and tweak it so that when you give everybody their upper quota, it gives the right number of seats. Okay, so he says, well, if I take my standard divisor of 50,000 and I find my standard quotas, if I round them all up, that gives me 251. That's too many. If I make my divisor a little bigger, it will divide in evenly so that when I round everybody up, I give away the right number of seats. Again, slightly different, but it causes the same problem. There's that 139.72 again. Remember, or sorry, 138.72. So I know that State B deserves either their lower quota 138 or their upper quota 139, but they end up with 137. By making the divisor a little bigger, what you've done is you've made your number not go in as many times. You're not giving away quite as many seats, but you gave away way too few to State B. In other words, you've got lower quota violations. So changing the standard divisor is a little bit dangerous because if you change it too much, you're going to end up with quota violations. So neither one of these methods really hold water. Along came Daniel Webster. Now this is Daniel Webster, who's this lawyer, statesman, senator, not Noah Webster, the guy with the beard who wrote the dictionary. Okay, so hang with me here. He says, let's find a suitable divisor. So he also says, hey, change the standard divisor, but do this in such a way so that when you round traditionally in the conventional way, that the modified divisors, the modified quotas, add up to the right number of seats. And the idea is that if you decide you're going to round everybody traditionally, you won't have to change the divisor quite so much. And if you're not making your divisor changed too much, then you'll be less likely to violate these quota issues. Now, this is basically a compromise between Jefferson and Adams, of course. So how do you make this work? You're going to start with your standard divisor, and you're going to find each state's standard quota, just like we do normally with Hamilton's method. Just like Hamilton. And we're going to check traditional rounding. If the number of seats apportioned is the number of seats available, then you're done. Okay, so traditional rounding, if yes, you're good to go. If the number of seats you gave away is too many, then you're going to want to make your divisor a little bigger. So if you gave away too many seats, you make your divisor a little bigger. A bigger number won't divide in as many times, so a bigger number won't give away as many seats. If your number of seats you gave away is too few, then you're going to make your divisor a little smaller and you're going to try again. You keep doing this until you find the right number. Again, it takes a little guess and check. Sometimes it takes several attempts to do this correctly. All right, so here's the Webster's apportionment. We've got Parador's Congress again. I've got my populations. We started previously in this chapter with a standard divisor of 50,000. Remember, that is the 12,500,000 total population divided by the 250 total seats. Our standard quotas, this is everybody's exact fair share. If you round traditionally, those come up to 251. Now that is too high. That's too many seats. So here's the logic behind this. If your standard divisor is 50,000 and you ended up with a 251, that is too high. You want to make your divisor just a little bit bigger. If you make it a little bigger, then it's not going to divide in as many times, and it's not going to give away quite as many seats. So what should you try? Well, you have to use guess and check, and you have to keep on trying and trying and trying. But I did that already for you, and one that I found that will work is 50,100. Now, if this hadn't worked, then I would have guessed again. So I'm going to try 50,100. Okay, so to take this population, you take your population, you are going to divide by 50,100 and then round traditionally, because Webster is all about traditional rounding. So 1,646,000, I'm going to divide by 50,100. I get 32.85, which rounds to 33. And 6,936,000 divided by 50,100, I get 138.44. That rounds to 138 because of the 0.4. When I write these decimals, I always truncate them instead of rounding them so that I don't accidentally round twice. 154,000 divided by 50,100 is 3.07. Rounded traditionally would go to 3. 2,091,000 divided by 50,100 is 41.73. Rounded traditionally, I get 42. 685,000 divided by 50,100 is 13.67. Rounded traditionally is 14. 988,000 divided by 50,100 is 19.72. Rounded traditionally is 20. And if you double check, 33 plus 138 plus 3 plus 42 plus 14 plus 20 does equal 250. Now, if it hadn't been 250, if it had still been too high, then I would have made my 50,100 a little bigger. And if this number had been too small, then I would have made my 50,100 a little smaller. So maybe 50,050, for example. So a couple of guess and checks should get you through this relatively successfully. Okay. So let's try some problems. Example 1. A certain country has 5 states and 240 seats in the legislature, and the populations of the states are as follows. Using a modified divisor of 40,100, find each state's modified quota and apportion using Webster's method. So the one thing I notice here is that I'm not going to have to do any guess and check. I'm not going to have to go through this process of, is it too high, is it too low, because all this information is already given to me. In fact, this is what a lot of your test questions are going to look like. When it comes to Webster's method, sometimes Webster's method takes a really long time to get through. So what I want you to understand is what to do with a modified divisor and how to round. Webster's method, again, tells me to round traditionally instead of rounding down like Hamilton and giving away the extra seats. All right, so let's start. I have State A, State B, State C, State D, and State E. Isn't that convenient? All right. I'm going to take each of my state populations and find my modified quota by dividing each of the numbers by 40,100. So 427,000 divided by 40,100 is 10.64. Again, I'm truncating these, not rounding these. 754,000 divided by 40,100 is 18.80. 4,389,000 divided by the modified divisor, 49,100, is 109.45. Our D divided by our modified divisor is 96.58. State E divided by our modified divisor is 3.915. Now remember that Webster tells us that we are going to round traditionally. So that would come up to 10.6 rounds to 11, 18.8 rounds to 19, 109.4 rounds to 109. 96.5 rounds to 97. And 3.95 rounds to 4. I'm going to double check really quick. 11 plus 19 plus 109 plus 97 plus 4 equals 240. That's what it's supposed to equal. Fantastic. And so this is my final apportionment. A has 11, B has 19, C has 109, D has 97, and E has 4. So again, you need to know how to work Webster's method given a modified divisor, understanding you need to find modified quotas, and then what to do with them once you get there. Now, what if you don't have the divisor? What if I don't give it to you and I forced you to do the guess and check strategy? Well, let's get started. A grandmother is going to distribute 225 pieces of candy to her 4 grandchildren based on how many minutes of housework they've completed over the past week. The table below shows the number of minutes each child spent doing housework during the past week. Use Webster's method to apportion the candy. I have no information about a divisor whatsoever, which means I need to start with my standard divisor. Okay, standard divisor is total population divided by number of seats. So I know that my number of seats is 225. 871, 1029, 610, and 190 add up to 2,700. So if I divide, I end up with a standard divisor of 12. All right, so we have Alex and Beth and Carl and Dave. Okay. I need to find their standard quotas. Remember, to get the standard quota, we're going to divide by the standard divisor, so I'm going to divide by 12. 871 divided by 12 is 72.58. 1029 divided by 12 is 85.75. 610 divided by 12 is 50.83. 190 divided by 12 is 15.83. And because it said Webster's method, my next step is going to be to round. All right, 72.5 rounds to 73. 85.7 is going to round to 86. 50.8 will round to 51. And 15.8 will round to 16. Put those together, that is 226. All right, that is too many. Okay, I'm supposed to give away 225. 226 is not going to work. So I need to take, I tried 12 and I got 226. So I need to go a little bit bigger. I'm going to try 12.1. Remember, if your number you give away is too high, then you want to make your standard divisor a little bigger. Why 12.1? I am randomly guessing. I don't know. I'm just thinking it feels a little bigger than 12.1. I was pretty close with this answer. Let's see what we get. So I'm going to try 12.1. So if your number is too big, go a little bit bigger with your divisor. All right. So now I'm finding modified quotas using a modified divisor of 12.1. Okay. 871 divided by 12.1 is 71.98. 1029 divided by 12.1 is 85.04. 610 divided by 12.1 is 50.41. And 190 divided by 12.1 is 15.70. Okay. I know that Webster's tells me that I am supposed to round. Okay, 72, 85, 50, and 16. 72 plus 85 plus 50 plus 16 comes up to 223. Okay, that's not right either. 223 is too small, so I need to make my number a little bigger. So if we think about this, when I tried 12, I got a number that was too big, so I went a little bigger, 12.1. When I get 12.1, I got 223. That's too small, so I need to go a little smaller, which means I know my number has to be in between 12 and 12.1 somewhere. However, I don't want to go right in the middle. Like, I don't want to go 12.05. That would be halfway in between 12.0 and 12.10. I don't want to go 12.05 because 226 is closer to what I want of 225 than 223 was. So I really want something that's like right there, sort of. So what about 12.03? Okay, that would be a little bit bigger than 12 because I need to be bigger than 12. And it would be smaller than 12.1, but closer to the 12, which I was closer with my seats there. The idea is that every time you get a wrong answer, you're basically ping-ponging in between to try to get a closer answer than what you were. You should, every time you get a wrong answer, be closer to getting your right answer. And again, sometimes it takes several attempts to do this. All right, so I'm going to try this again. Modified quota. This time I'm going to use my guess here of 12.03. Okay, 871 divided by 12.03 is 72.40. 1029 divided by 12.03 is 85.53. Again, I'm truncating these numbers. I'm just chopping them off. 610 divided by 12.03 is 50.70. And 190 divided by 12.03 is 15.79. I'm going to round. We get 72 and 86, 51 and 16. 72 plus 86 plus 51 plus 16 is 225. That makes me very happy. That's the right number. If this number had been wrong, then I would have guessed on one side or the other. If it had been too big, then I would have guessed a little bigger than 12.03, maybe 12.04. If this number had been too small, then I would have guessed a little smaller, maybe 12.02. Okay, so every time I do that, it gives me a better answer. As of right now, this is my final answer. When you do this on your homework, if this takes you more than one page to do, or if you have a bunch of scrap paper, make sure that you explain which divisor you used and attach that paper to your homework as well. Okay, so again, 3 attempts, that's not bad. Sometimes it may take you a little more, sometimes it may take you a little less. You may want to try plugging this into Microsoft Excel and having it do the arithmetic for you. So all you have to do is, change your divisor and it'll round it for you until you see the right total come up. So if you're good with Excel, you might try to do it that way too. All right, one more. 4 friends are lost on a tropical island. Luckily, the friends find a stash of 75 coconuts. Coconuts will be apportioned based on the weight of each person. That is, the heavier the person is, the more he gets. The table below shows the weight of the 4 friends. Find a modified divisor and apportion the 75 coconuts among the 4 friends. And it doesn't say this because I forgot to type it, but you're supposed to be using Webster here. So you might want to write that so when you look back at your notes, you remember what you were doing. Okay, there is no information about the divisor, which means we need to start with the standard divisor. Okay, standard divisor is total population divided by number of seats. We're splitting 75 coconuts, which means 75 seats. Total population would be total weight, so 220, 173, 157, and 200. If we put those together, that comes up to 750 pounds. 750 divided by 75 gives me a standard divisor of 10. 10 is my favorite number to divide by. All right, so here we go. Let's start with Chandler and Ross and Rachel and Joey. All right. I need to find my standard quota. Standard quota I would get by taking everyone's weight and dividing by the standard divisor of 10. So 220 divided by 10 is 22. 173 divided by 10 is 17.3. 157 divided by 10 is 15.7. 200 divided by 10 is 20. And remember, Webster says that we are going to round traditionally. Now, you don't have to round 22 and 20. They're perfect already. 17.3 would round to 17. 15.7 would round to 16. And if I put those together, 22 plus 17 plus 16 plus 20 is 75. That makes me very happy. I am happy because that is the right number, which means I don't have to do anything else. I don't have to modify to my divisor because my standard divisor worked. Remember, our problem with traditional rounding was that it didn't always work. Sometimes it does. You can't rely on traditional rounding all the time. So when it works, stick with it. Webster says, hey, that's good enough for me. If it doesn't work, if it gives away too few, modify to make it a little smaller. Okay, if it gives away too many, modify your divisor to make it a little bigger. When you go to do your homework tonight, you have a worksheet, and the first two questions on the homework, number 1 and number 2, those are going to be a lot like the example number 1 here in your notes. So you're already going to be given the modified divisor. All you need to do is figure out the modified quotas, and remember that Webster wants you to round traditionally. For numbers 3 and 4 on the homework, those are going to be a lot more like example number 2 and 3 here in the notes. Okay, you're going to have to start with the standard divisor and check it out. Okay, sometimes the standard divisor may work, sometimes it won't. If it doesn't work, you have to use guess and check to try to find something that does work. Okay, if you check, 10 different numbers and you still can't find it, it's okay to go ahead and stop there, but you need to keep finding and finding and finding and checking and checking and checking until you can get that right number. Okay, 4 questions on tonight's homework. It's a worksheet, and good luck with that. Okay, that is due tomorrow. So make sure that you get that done. Good luck.